I'm good here. Alrighty. Hello, everyone. Welcome. I'm Chris Hyzer, TJBChris. Some of you watch my YouTube channel, some of you don't. I'm cool either way. Welcome to Exploring 513. This is a look at the VIS. And I'm going to apologize in advance because there's a lot in this, and this is the MS-DOS portion of our show. And I know how much we love to talk about MS-DOS around here. For those of you here for the VIS, the Video Text Information System on Xenix, I'm sorry to disappoint. The door's over there. I'm sorry, this is not that. This presentation is not one where I read every word on the slide just as it's written. Fortunately, I put that joke in there and I was like, I'm going to have to take that out if any of the presentations do this, so thank you all for not doing that. So who am I again? Christopher Hyzer, TJBChris. I was your Radio Shack kid. First computer was a Color Computer 3, and I contend, and will meet you by the bike racks to defend, that the Coco 3 is the best 8-bit computer someone growing up in the late 80s could have had because of the combination of real operating system with things like pipes and processes and even a security layer versus some of the other 8-bit micros, your Commodore 64s, your Apple IIs, and the like. And it's really where the basis of my life, my career, and all of this has come from. I was instantly a Tandy kid beyond that. Started collecting machines in my teens. My first was a Model 4 with one of those DMP 400s just over on the table, the light dimmer. Particularly appealing about Tandy computers, and this is something I've tried to sell at places like VCF Southwest. Radio Shack is the one place where you could go into the store in 86, 87 and have 6 or 7 different foreign architectures in the same place at the same time. So think about this. You've got your 8086s, you've got your 6809s, you've got your 80C85s and the 100, the 102, and the 200. You've got your 68000s, right? You've got your Pocket PCs, which are a number of their own by themselves. And you've got your Z80s 134, 4P, 4D, and the like. And let's not forget that the 212. Now, if you count the Tandy 2000 as its own, there are 7. So, but I'll leave that to you. I am not many things. I'm not old enough to have contributed to anything meaningful in Tandy's heyday. I was a kid. I'm not a real software engineer. Scaffolding, duct tape, friends. Lower your expectations. I am not an expert on low-level x86 architecture, and full disclosure, until June of this year, I had never done anything on an x86 that was not abstracted from me by a compiler and standard lib or something else like it, like libc. Never done any assembler on it. I've done it on a couple of other platforms in the lineup. Certainly had no experience with the segmented memory model of the x86. Have fun there. I've never used a DOS ISR. Thank you, Joel, for dropping ISR earlier today, so I'm not the first. And really had never done any of this. So everything that I'm talking to you about, I reserve the right to be wrong, and 3 months ago would have known nothing about. So here we are. So what is the VIS? We're going to go through this a little fast. Again, it's not Video Text Information System. The VIS was Tandy's answer to the brainless child activity of zapping a gazillion Xylophons. And this is a phrase they used in their marketing, and this is also a phrase that Paul Schreiber harnessed when he did his TA talk in 2019. And the idea here was this was marketed to parents, mainly as an alternative to Some Clown with a Gun, our friend in the bottom left. Many of the titles were educational or reference or edutainment. Some games, though most had an educational element. There were some fairly good games for the system. Link's Golf, although a little pokey, is actually one of the better uses of the platform. It came with a sampler disc, which actually has a pretty good game, Space Nuts. You should play it. It's pretty fun. And Compton's Multimedia Encyclopedia for $6.99.95. It was pricey. Little owl man there in the middle. I don't know his name. I don't know if he had one. And that family on the right is the stuffiest plastic family they could have found for the 1990s. It's just big smiles, and they were your 90s family. So this is going to look a lot like a PC for the most part to start. And that's because from its core, that's what the VIS is. It's 12 megahertz 286. It's got a mega RAM with XMS. It's got an 820 handler. No isobus. When you lose the isobus, you lose the overhead, and you lose the wait states. So you get a little more performance out of that 286 processor that's in there. You've got the same video RAM DAC that's in the Sensation, the original Sensation, 251650, not the revision one that came out in 93. That RAM DAC has some special functionality for handling things like overscan and interlaced video and things like that. The AdLib Gold, same standard as the Tandy Sensation, which, fun fact, went defunct right as the 2 came out. Mitsumi CD-ROM drive. Now, I can confirm, I just did some work on this, it is at least tangentially related to the Mitsumi interface. You'll remember back in the day there were 3 main interfaces that were proprietary for CD-ROMs. You had Sony, Panasonic, and Mitsumi. But it's not the same. The driver bulks if you try and connect the drive to a regular Mitsumi controller. Wireless infrared controller. Save-it card, Dallas Semiconductor cartridges for storing application data. And you could get some additional hardware. You could buy more Save-it cards. And you could get wired controllers. Hint, if you are playing a 2-player game, be the wired player and you will win. If you're playing with 2 infrared controllers, be player 1 and you will win. Additional controllers available. There was a 2400 baud modem also available. It's the same modem as the Sensation. The modem exists because it existed in the Sensation, but it was never used in the VIS for Radio Shack stuff, but it was used for things, insurance companies would use these things after its fate happened, and they did use the modem. So the modem and VIS functionality did see some use outside of retail. So what happened to the VIS? It did not do well. And the following I take, this is the figures that I could find that most agreed between what Paul Schreiber had said in previous discussions and what Frank Dirtifor had also said in various Usenet posts. Christmas 92 to Jan 93, about 45,000 units. About 9 per Radio Shack store, with about 6,500 company-owned stores at the time, 6,000. 1,100 sold. January sales were negative. About 200 came back. Production stopped on or around January 10, 93. Post-Christmas 1992 fate, that $699 price tag went down real quick. It was in the 94 catalog, never showed up by 95, it was gone. They got sold, liquidated to Tiger Direct, who sold them often for 20 titles and a system for $99, well into the mid-90s. Reviewers of the day were not terribly kind to it, and YouTubers now who look back at it coming without any knowledge of what it was have also not been particularly kind. This is just a quick look. The left, aspirations. Now, if you're a kid old enough to read this, as soon as it's television for developing minds, I was about 13 or 14 when this thing came out. I would have been out, other than the fact that it said Radio Shack on it. And then the Tiger Direct ad. So where are we today with the VIS? So lots happened. First off, this slide should really be thank yous and acknowledgments. Tandy Showcase, Ed Malfris, who isn't here, but I guess is watching, so hey, Ed. Maintains a website, tandyvis.com. Really check it out. He's got a lot of great stuff there. He's been talking with folks. He talked with Paula quite a bit, collecting a lot of information. I know he's got some of the collection that came from Frank's collection and the like, and preserving that on his site. He's got Tandy Q&A notes from King's Quest V, which never actually saw release. He's got developer presentations that Microsoft and Tandy gave. He's got a whole lot of information on the VIS, modular Windows manuals, pictures of his Pyramid OVIS consoles that he has, and a lot of great stuff. He's been very helpful in my efforts. He's loaned out some things to me to borrow and explore. You're going to see that. If you watch my YouTube channel, you'll see that later. He's also donated some things to me for the effort, so thank to Ed. And a lot of that comes from 2 other folks that I'll really name here. Frank Dirtifor and Paul Schreiber retained a lot of what they had when they were at Tandy, and I know a lot of y'all did. And I look at my career now, and I don't think I want to retain any of it, honestly. Who cares? I don't. But these folks kept it. Say what you will. Frank especially had a large online presence with his Usenet posts and things. I try to take the factual end. If I cite them in this, I know that these are people, and they had their own perspective and commentary, and that came through in what they wrote. So, take it with that perspective. But a lot of the information that I knew about the VIS, a lot of my interest came from what they did, what they had to say online at presentations, and what they preserved, and then some of you here were able to collect after Frank passed. So, and if you haven't seen Paul's TA talk for 2019, do check it out. It's very good. He talks about VIS among other things, and he has a very good personal spin on it, which is a whole lot of fun. VIS does have some emulation available. MAME does have an emulator. It is in progress. It works. It supports most of the titles that were released for the VIS. However, as it will warn you when you run it, there will be some graphical glitches, things like that. New and unreleased titles don't work. None of my homebrew will run on it. I do have an unreleased copy of the game Lemmings that Tandy was working on, and that won't run on it either. But I imagine that'll change. I haven't directly spoken with the developer, but I do know he's active. So That probably will change as some of this stuff kind of comes out. You can find that at maimdev.org. And at the bottom, I have a little quote here. Keep in mind, this was effectively a 286-based Windows PC with no disk cache, running software from a CD-ROM drive. Now, this is their opinion. It shouldn't come as a surprise that it wasn't popular, earning the backronym virtually impossible to sell. Which I think it had that acronym then. OK, so now is where we get to the fire hose. I'll probably have to jump around. Anybody know what movie this is from, by the way? Yeah, all right, we've got some UHF fans in the house. If only Die Hard can come out and ruin the momentum, right? So you get to drink from the fire hose. So the VIS architecture is IBM PC-ish. It's founded on the IBM PC, but it's very heavily customized for your set-top box and kind of your locked-down, non-general purpose computer. So it's got a Phoenix BIOS. All the Tandy BIOSes I know of are Phoenix. If Tandy designed it, someone's going to say, well, TJBChris, what about the Tandy 2100? And I'm going to tell you that that was a slap together from Parts Machine after they were gone. So that has an AMI BIOS in it. It supports Intel 8254 interrupts, so you've got your N8H calls. It's based on the standard paradigm of BIOS DOS application. Some of the DOS IOSR calls, and Int 20 and 21 are there, untouched. Most, especially the ones that relate to file I/O, are either redirected or many just don't exist. And some of those you'll run into that pretty quick. The standard BIOS routine is there, including an option ROM scan. In fact, the option ROM scan is how the thing actually does boot, having no hard drive. It does have the VIS enhancement supported by BIOS calls. So you don't need a driver if you want to do wavetable audio. You don't want it if you want to do synthesized audio or worked with the hand control. You can call BIOS IOSRs to do that. The video is VGA. It's got the Sensation RAM DAC in it, but it's a very subset application-specific version of it. So we'll talk more about that, but there's missing modes and there's other things like that. There is no, I preface this very poignantly, it's worded carefully, there is no file system-based writable storage. You don't have a drive letter. You don't have things like if you're going to try an fopen in C, for example. That's just not going to be a thing. And specifically, I'm going to focus on some of the big architectural differences that you're probably going to run into if you try to port something or write something for the VIS and you're used to an MS-DOS ecosystem. Specifically, keyboard compatibility. The BIOS documentation for this specifically calls out that the keyboard is not 100% AT compatible. Specifically, if you hook int 9 to get keyboard scan codes, this bug is killing me, as most do, that's not going to work. And I've seen this in experience. The keyboard will act strange, it won't work correctly, and you won't get any keyboard input from it. There's no real-time clock, so you lose the interrupts. It doesn't know what time or date it is, it doesn't care, and there's no software interrupts there or anything else to support it. Limited video mode support, and this goes back to my last slide. Not all VGA modes are there, some are. Not all VGA modes are there, some are. There are no text modes. There are no character sets available to you. So this is the kind of thing, this was meant to be a graphics-only platform entirely. You can work around that, and we'll see there are some things that do. EGA support is interesting. You don't have support for custom palettes. There are 4 preloaded palettes in ROM. If you try to insert a value into a palette slot, it'll look, and if one of those 4 matches, you get the entire palette. So you might not get the colors you expect. They chose pretty standard palettes, so probably 6 out of 10 times you'll get what you want, but VGA does have full customizable palettes. So it really, and I should mention, the VIS also does have a lot of OEM implemented modes. It supports planar modes, YUV, direct color. A lot of these OEM modes they do have demonstration materials in with the modular Windows documentation that actually show off these modes. And they're pretty impressive. They're background and foreground layers and some other things like that. And taking a look at specifically the VIS-specific services. So when you put a piece of hardware together that has things like sound or a hand control device that's not common on a PC platform, you want a standard way to access that. So what Tandy did was extend the BIOS at int 15 and made a total of 8 system services available to you that you could use to access the VIS hardware. And again, this actually makes it easier. It's easier than using a driver or anything else like that. So you've got your system services, what is the system, who is your daddy, and what does he do, You've got your hand control services. You can either poll it or you can set up an interrupt service handler routine and have it to give you button up, button down interrupts. You can do waveform input and output. I don't know that anything ever did input, but there is a mic jack on the thing. Synthesizer services can also be done. There's a mixer. The plus side to the mixer is it defaults to max volume for waveform and synth, but all others are muted. The mixer is complicated, and the documentation makes note of this. And the way that I interpret the way the doc is written, it's okay, buck up and deal with it. That's kind of how it is. The mixer is complicated, but it is very powerful. And there are timer services. If you want your 8254 services beyond int H, you have things like that. There are also some MISC services for getting keyboard scan codes and replacing that missing int 9 hook functionality if you want to do that. So on top of this, of course, we have a limited BIOS. We have a limited underlying hardware platform. Let's take MS-DOS and chop it up too. And I guess what we're doing we're going to pick a really nice code name that matches the short and sweet version of DOS we've got. It's Haiku. That was the code name for modular Windows and DOS. DOS is a MS-DOS 3.2-ish environment. That's the version it reports. But it's not just DOS 3.2 from your PC. And again, it contains a very limited subset of int21 calls. The ones particularly related to file I/O tend to be either modified or missing. Your drive letters, for example, all run through the redirector, MSCDEX and the like. In fact, you've got two drives on there, A and B. A is your CD-ROM drive, and that goes through MSCDEX. B is your save it card, but only if it has executable code on it. And it only supports one file name, card.exe. So if you want to use your save it card for game data or anything like that, you don't do that through your B drive. That's actually done through another method I'll talk about later. There's no command com. There is a command binary in there, but it actually initializes the VIS BIOS. You do have 384K of extended memory. It does, as I mentioned here, have DOS and ROM, but it's not like your Tandy 1000 DOS and ROM. If you boot up a HX, SL, TL, RL, any of those machines, you get an A or a C drive with a ROM with the DOS file system on it, or you can browse the files, find deskmate, find command com formats on there. This doesn't have that. There's no drive letter for your DOS files. They're all stored in a ROM resident table of contents format. And the way that they're actually implemented is following the binary name is an E9 instruction, a relative branch, and then the next 2 bytes are your relative branch address. And it's usually just down further in ROM, and then that has a subsequent branch out to wherever it is actually in ROM. So that is something to get used to. There's not a fat overhead in ROM would have been a waste of space. So you've got this kind of table of contents model. But there is a shell on VIS. There may not be command.com, but with the Windows, with the modular Windows development kit, there's a utility called browse.com. Browse adds additional BIOS extensions and repurposes one of the graphics screens to simulate a text screen. So it throws in some of the int10 calls that you can call to put a character on the screen or do things like that, but it's very primitive. It won't even render a tab properly. But it does do a good job of allowing you, if you're maybe taking 3 or 4 versions of something, you load them all onto a disk and you have it boot into browse.com. It gives you a very basic shell. It supports dir, cd, cls, help, and a command to run code from the save it cartridge. It also has a couple of extra commands if you have some of the VIS development hardware in your console. It uses a lot of memory. So if you find that your application's run out of memory and you're playing it with browse.com, you might not want to run it through browse, try it by itself. And that is in the archive that is now kind of been floating around. It's on the Discord channel. You'll find it out in my Discord channel. Burn that contents of the CDG folder onto the root of a disk with an ISO 9660 file system, and you will get browse.com on your VIS. You can plug in a PS2 keyboard, and you can interact with it. And this is what browse looks like. On the left here, we have the help screen. As you can see, it's very limited. And on the right, I wrote a little directory utility. I was trying to suss out if there were other drive letters in there. So I wrote a couple of utilities to scan all the MS-DOS drive numbers, and I wrote another one just to let me list any drive letter I choose to make sure browse wasn't just trying to hide it from me. From pro tip, it was not. So the other half of this is modular Windows. Microsoft really wanted you to develop for Windows. Their documentation clearly is bent on sending you there. It's a very heavily customized version of Windows 3.1. And it has a modified kernel and GDI and user.exe. So a lot of the Windows 3.1, even underlying services you might expect, might not work the way you want. It has support for the custom VIS video modes, VIS sound, the hand control, etc. So the hand control can act like a mouse. So if you're writing applications for modular Windows, it actually does abstract a lot of the hardware differences from you if you want to deal with the relatively easier modular Windows differences. And it does have custom controls. All the buttons, all that stuff are rendered through something called tvui.dll. So your standard controls, a lot of those are going to be missing. There's no scroll boxes. Combo boxes are going to be different. There's no maximize and minimize buttons in Windows, and there's no menu bars, and there's a whole lot of other things like that. There's no common dialog. The standard open and save as dialogues you had in Windows 3.1, you're not going to have those. It's configured with a customized system on INI. When I say cut down, you can probably do it in some implementations in 10 lines or less. System INI and WinINI will let you customize your application, set up your multimedia bits, and also, interestingly enough, your application is the shell. In System INI, shell equals awesome.com, or whatever it is, and that will be your shell in Windows 3.1. That's what VIS will start. Most of the real Windows files are in ROM. You don't put them on your disk. So there's another separate table of contents in ROM, differently more formatted from the DOS one, because let's make this fun. And that has all the Windows, DLLs, EXEs, all that stuff that you're used to. There's no program manager. There's no shell. Well, asterisk. There is on the Windows SDK a demo shell called winshell.exe. So if you have the modular Windows SDK CD-ROM, plop it into your VIS. You'll get the Windows Shell, WinShell demo application, and there's 2 demo apps that come with it, Reversey and Slideshow, which will show you a lot of the VIS video modes. And it's actually worth checking out on a real television if you want to see how they have the same image multiple times in different formats. And it really is a good way to demonstrate how capable the video hardware in that really was. There's also an MC-Man utility for managing the memory card on that disk. And you can set up, again, your basic multimedia support. So if you want to play with WinShell, just burn a copy of the disk and pop it into your VIS. So what's it like to develop for the VIS? What happens when you kind of come in the door? What do you get? Where do you go? Where do we go now? Well, there's software documentation and utilities. So when you go to Tandy for this kind of thing, you're going to need license keys. We're going to talk more specifically about licensing, so I won't get into it here. Obviously, your developer agreement, whatever Tandy wanted you to sign to develop applications for the thing. You got your BIOS call documentation, Tandy included with modular Windows, a doc called visbios.doc that outlines all of the AT services that are changed or non-existent or that are there, as well as the AT BIOS functions that they added for VIS. And it's very well documented. It's, as many things Tandy wrote in documentation-wise, it's well documented. I was able to do it, folks. So if I can do this from zero, it really was very easy to follow. And operating system API documentation, again, steering you to modular Windows. The Windows SDK, of course, does not include your compilers or assemblers, but being Microsoft software, they expect you to have Microsoft C++ 7.0, Visual C++ 1.52, 1.51. Those were kind of the compilers of the era. You also got a license generation utility, which we're going to talk a whole lot more about. MakeTat. You got your library files for VIS-specific hardware, so you got your hand-controlled DLL, you got your TVUI DLL, you got memory card libraries and things like that. And you got some PC-side development and debug utilities, as well as some VIS-side utilities if you had development units. And you got some sample source code. So source for WinShell, for the Reversey game, a lot of that stuff is out there. Apparently Tandy had DOS-side code too. That's what I inferred, but I haven't seen that. It's not part of what Microsoft gave you. Aiding the developer were PC expansion cards, the ultimate in unobtainium. These cards allowed you to turn your AT-based PC, preferably a 2 or 386, into a mostly VIS. It allowed you all the custom hardware that you got in the VIS, the RAM DAC, the AdLib sound, the hand control, the CD-ROM interface, and a Save-It card interface. You could stick a Save-It card into the ISA slot of your computer. And for the VIS, a serial loader card, a debug card that could both transmit data back and forth and was capable of loading binaries to the VIS from your host PC. And taken directly from Tandy Showcase's website, these are the cards, these are the pictures on his site. You can see there, top left, we've got your audio card. On the right, we've got your CD-ROM and your Save-It card. Then on the bottom, that looks like your video. We've got your IR card. And finally, on the bottom right there, we've got the debug card, which goes into your VIS. And that's got custom ROMs. Many of these have the custom Tandy ASICs on them, so I don't know that reproduction will ever be a thing for many of these cards. But they are, I think I know of four people that have these, maybe 5? There are not many of these. Finding these is not going to be a thing. I don't have them. Primary references, again, the modular Windows SDK, we talked about that. It does provide some reference on what DOS calls are there, but it doesn't go into detail. And if it's not in the list, it's not implemented. That's how you read that documentation. It is mainly focused on VIS, though Microsoft tried really hard to differentiate that VIS is just one of many modular Windows platforms that are or will be available. And it did mainly focus, again, it had sections on VIS. And of course, again, I mentioned the Tandy VIS platform, and BIOS reference is really important. That's probably your first read, honestly. And that actually was, there's pre-release versions of that BIOS doc in the files that we got from Frank Durda. But again, it covers AT stuff, the VIS calls in great detail. Really easy to work with. So how do we get into the VIS? The VIS is interesting to me for a few reasons, one of which is that it is one of the few MS-DOS style platforms that was not meant for you to be able to just run general purpose stuff. It had a security system. You couldn't just go plop a disk in, it won't necessarily work. And there's keys to the kingdom, so to speak. The VIS will not run an application from a CD-ROM without what I would call the magic cookie file. And this is a file that is generated by a Tandy-provided utility called maketat. The magic cookie is a file called control.tat. So if you've heard me on Discord, back and forth, has anybody come across maketat in any of the stuff you've seen? That's why I've been asking. Without this, barring some hackery or trying to mess with the ROM on the thing, we weren't going to be playing around in here. So what you get is a text-based job file where you get to specify the name of your application, the license key that Tandy gave you for your application, and then some configuration information that we'll talk about. It is a signed-ish file. It's actually algorithmically based on Unix crypt with a custom rotor. So the file is tamper-resistant. You can't just go and edit it. So you might be thinking, oh, I'll use a hex editor. I'll change the name of the executable in there. It's not going to work. It tells, again, VIS what to run, configures the environment. Do you want DOS or Windows? And VIS does have a menu system. You can set up a menu system that the thing will pop up, and you can put custom pictures for icons on there, map buttons to programs. You can even do submenus, things like that. For Class A titles, we'll talk about what that means. So basically, the basic process is you create your job file, feed it to maketat, it gives you control.tat. You put it on your disk. So in addition to maketat, there are a few other utilities. The save it card is capable of running code. There's a little asterisk on that. And when you do, it has to have the tat file there. You can't just put the executable, and it's combined into one to make that run. But the maketat M allows you to make the maketat for the utility for the save it card. And within Tandy, there was a licensed utility called register.exe. Frank's posts on this, Frank Durda 4 wrote it. His code, his comments are fun to read. But he appears to have been the person that ran it, and it relied on a file called register.dat, which, near as I can tell, is a hand-edited text file that he kept with a record of all the bits. This was in that archive that came through. It's on my Discord channel, so if you want to see the numbering system, some of the titles that were planned for VIS didn't make it, some what did make it, contacts for the vendors are in there, so that's why it's not out public, but it's a really neat file to look at, and those two would work together to generate you a license key to determine whether your title was, how it was licensed and things like that. The source code and sample job file is very well documented. With the sample job file, I was able to create a control.tat in minutes. It's really well written. And it's on GitHub now. Unless I get sued into oblivion, the maketat utility, but not its source, as well as a sample registration database and register.exe are on my GitHub. Check out the Memorex VIS repository. There will be more as I do sample code, and some of the stuff I've written playing with it, if you've been following the project, will make its way there, as well as some other stuff you'll see. And I mentioned Class A licenses. There are two, asterisk, license classes for the VIS. The first is your Class A title. Class A's are a fully supported licensed title, License A. You had full rights to use the VIS logo on your disk, on your packaging, in your application. It provided all VIS player functionality, which generally translates to the menu. And when you boot it up, you'll get the legalese Authorized Video Information System title on text will pop up before the application starts. Your other license was Class C. Your Class C really seems to have been more of a developmental license. I don't know of any retail titles that came out with this, but I haven't gone through all the titles. The application can run. You get modular Windows or DOS. You didn't have the rights to use the logo, and you couldn't use the menu system. It also would not display the authorized title text when the title booted. So if you make a disk with browse, for example, it's not going to say it's authorized. It's just going to boot. But wait, as Billy Mays would say, but wait, there's more. There was Class D. Frank Durda talked about this in a Usenet post once, but didn't go into a lot of detail. It was hidden. It functions as a Class C developer title, but you get a different key out of it, so the player knows. According to Frank, it unlocks basically any VIS functionality that would have been locked or limited for you had you run an A or C title. And it was found, I did find an alternative copy of the register utility with the source code that has support for a Class D title. So that's how I found out it rolls back to a C. I looked through the code. It does work. The titles will run on VIS, but to my eye and having not really dug into it, it doesn't seem to do much different. So this is kind of what we're looking at in terms of what this looks like. On the left there, I've got a job file, and you can see it's verbose in its help, even to the point of having numbered fields, so you can see how long your fields could be. You can see there's a sample title in there. There's an example program. There's examples further down for running an application in modular windows, for example, min-win. This was a C application, so if you used a backspace, you had to escape them. So, and on the right, you have a sample output control.tat. Fun fact about control.tat, hidden just after the human readable text at the beginning is a Control-Z character, so that if you run it with a type command in MS-DOS, you won't get the rest of the binary. It'll stop after the title and the copyright. And this here is a copyright in modern, now HD, the registration database. This is just a little sample of it, of what that file looked like. And again, vendors had the same vendor ID number, and you had application IDs, and they were all grouped together by vendor. So this was very much a handwritten show. So where does this all lead us? Those of you who've been following on the Discord, I've been pretending but not pretending like it's, I've got a big special thing for VIS. All right, prepare to be whelmed, friends. Not overwhelmed, not underwhelmed. I'd like to present to you the first new playable title for the VIS since 1993. I mentioned when I got Prince of Persia to run that it was the first new title to run on VIS, so you couldn't play it. And the game engine source was released in 2014. And if you'll excuse me, I'd like to take a little trip to Manhattan. Just like the YouTube videos, friends. Oh, whiskey break, never hurt anyone. So we now have a playable version of Commander Keen in Keen Dreams. The source code for this was released in 2014, but not the intellectual property, which means I can and eventually will distribute binaries you can use to make a disk of this, but you're going to have to get the game asset yourself. Joel, you're welcome. It was Joel's suggestion of Keen that got me searching. Keen Dreams was the one that was later used for other ports. Someone's done it for Keen 1 through 6, but that engine is a little more convoluted to get to work. This was a more straightforward exercise than some of the other titles I looked at. The game is playable. It's, again, scaffolding and duct tape, friends, but it is playable. It is a whole lot of fun to play. So what are the first steps? I'm going to walk through what was it like for me starting from 0 and trying to boil about 4 oceans at the same time to make this DOS application from a Tandy 1000 run on the VIS. Well, first thing you got to do is get Commander Keen. Run it on the PC. Knowing what I've already read about the VIS, look for the obvious stuff. I know VIS doesn't support text screens. I know that there's video modes I can probably identify by eye that are just not going to play well. Give it a run. See what happens. Okay? Then I'm going to use a utility called DOSMon, which is included in the modular Windows SDK. DOSMon is great. It will go through and you set a terminal up on your COM1, set it to 9600 baud 891, the usual settings, and it will spit out file calls. It'll spit out the file names you access, and it will spit out any unsupported int20 and 21 calls that come through it. Now, it won't catch non-DOS calls, so if you call in video modes or anything like that, it's not going to catch that, but it hooks int20 and 21. It slows your application dramatically, as you would expect, but it works exceedingly well. Okay, if all looks good, you go out and you get the Commander Keen source, you take a look at it, and then you realize something. All of these game houses back in the day, Epic, Apogee, Softdisk, a lot of these folks that wrote these games were people in home or small groups of people, weren't necessarily corporate folks, would sell them to these publishing houses. They used Borland. Borland was the accessible, not overpriced tooling that you could get. My first compiler was Borland Turbo C++, right? You didn't really have Microsoft compilers available to you. So anything that requires a Microsoft library could be a complicating factor. This was written in Borland. I used Turbo C++ 3.1, and you need Turbo Assembler because it's got some assembler in it. So the first thing, of course, get the code. Can I actually make this run? Can I make a version of the game that just runs untouched? Run it on the PC. Compile it up. Get the project set right. Make sure all the settings are good. Try it on the PC. Does the game actually work? Does the executable look like it should? Yes, we proceed. So this is just some looking at my testing for this. We can see already we've got red flag number 1. We have a text screen. First thing it does when you start it up, let's pop up a text screen. On the right here, I've got the DT100 because if you're going to do this, you're going to do it right and use a Tandy terminal to output your serial port payloads. A number of int21 calls. There were some others in there. There were some 44s and such that didn't really seem to stop the game, but there were a lot of file calls. And you can see here I have the code over there in Turbo C++ 3.1, got the project all set up. So we had a few things to look at. So taking a closer look, what were we looking at? Well, we've got text mode calls, but this isn't so bad. They're really only at the beginning, and they don't do anything material to the game. I don't have to interact with them. They don't do like a lot of games did and say, do you want Sound Blaster support? Press C to configure. Didn't do any of that. Graphics mode. Int 10H, it uses 0D. That's a supported EGA 16 color mode, 320 by 200. Perfect. Bad. It hooks int 9 for the keyboard. Okay. Good. It has ad-lib sound. Fun fact about Keen Dreams, it has the ad-lib engine, but it doesn't actually use it. Bad. It detects Tandy weirdness. That's a quote from the source, Tandy weirdness, and tries to null around it. What they're doing, they didn't say, they just called it Tandy weirdness, and then code follows. And then finally, it does look for file activity, but, well, it does attempt to read and write. If it fails, the game says nothing and continues. It just makes assumptions or doesn't do anything. So, boiling it down, text mode, keyboard hook, sound routines, it's only PC speaker effects we found out. Which, by the way, I will admit, I chased my tail for about 2 hours trying to figure out why there was no sound on the VIS. And then I argued the effing M, where at the bottom of the help file it said, yeah, we wanted to put sound in this, but we ran out of time and space, so we didn't do it. I felt smart, friends, smart. This is why we bourbon. And it does store high scores and level data to disk. However, again, it fails silently. So I can at least move on without having to worry about that now. We can come back and revisit. So text screens at startup. First thing we have to do is deal with that. Well, again, they're not interactive. You whack a key and they move on. The text screens don't contain anything useful. Soft disk presents Commander Keen. Woohoo. The calls to the text screen will crash the game on VIS. If you run it if you just run it from a disk without browse.com, it just reboots over and over and over again. If you run it from browse.com, it'll just drop you right back out to your light shell. So go find and remove the calls. Well, after a little bit of breadcrumb trail following, you can see on that far right picture the offender. We said AL to 3, that's a text mode call, and then we call int 10. Well, that's not going to work. So it turns out that they had a kind of a two-step function call that I could use to null this out, and if I commented it out, the text screen didn't appear. So if I comment this out and I run the game, will the game run? Will the game work? Fun fact, yes, the graphics screen came up. And if you let it sit there on the VIS in the state, it'll just alternate between the text screen, or the title screen and the high score screen. So I'm like, all right, this makes it worth continuing. So now I have a wish list. We're on the VIS. I could rewrite the keyboard routine to use the redirected int15 calls for the keyboard scans. But keyboard's an optional accessory. I want the hand control. Let's make this the VIS, friends. Let's do this right. Well, I only want the keys that are needed to support gameplay. Unfortunately, this game's fairly simple. Left, right, up, down, and you've got a jump and a throw. And there's a couple of other keys to escape and pause, something to pause it, something to get out to the menu screen. It does take names for high scores, but that's something I can fix. So what I did is, I'll put in a list of random names or phrases and just let it pick one. Again, now, if ever there was a demonstration of the fact that random is pseudo-random, because of the state of the VIS, and it always starts up in the same state, you always get the same ones in the same order unless I go and deal with that. Which in this version of the game that I have now, I did not do that because I had better things to do. But that is something that you would probably want to do. You can see here the initial keyboard routine on the bottom here. There's a function called start keyboard, and that actually is our offender. So that setvect key in is a constant set at the top to 9x. And it clears, this key hook isn't even a thing. And on the right, the input routine for this is funny in that it reads the port for the keyboard, gets the first byte that it finds, and chops the rest. And then it has some, is it pause, is it a special key, that kind of thing. And I will admit, the keyboard routines for this are interesting in that different areas of the game scan and use the keyboard differently, complicating things greatly. So when I worked on this, I realized I was going to have to work within the parameters of how the game worked. I couldn't try and boil an ocean without having to try and rewrite a lot of these I/O routines. Okay, well now we want to do this. We've got to learn about the hand control. So in learning about the hand control, I kind of wanted to demonstrate something with the VIS, and that's that despite being very different, a lot of tooling is available to you. Yes, I can use Borland Turbo C, especially if I don't want to use Microsoft-specific libraries. I can even use something like QuickBasic. So I wrote my very first ever assembler with Microsoft Macro Assembler and wrote a short int15 poll for the hand control. So set up the registers, call it, and you get back the routine returns hand controls. And I was able to then port that over to pull it into QuickBasic. And I wrote a QuickBasic exe. I run it on the VIS and see if I get hand control values back. And on the left here, we have where everything comes. So the hand control 1 and hand control 2 come back to you simultaneously, which is fantastic. You get two 16-bit values in the CX and DX registers. So you don't have to go back for both controllers. It kind of keeps it fair, right? And 10 of the 16 bits are used. So some were reserved. Future versions were allegedly going to have more buttons on the hand control. And the result, for those of you who have seen this, I'm sorry, but the result was really breathtaking, friends. I'm going to see if I can. This is browse, by the way. And look at me in the screen. We now have a triangle that moves on the screen. Now, it's wow, woohoo, but it worked. And when it worked, I'm also bad at making sure I clean up after my triangle when I move it, so it kind of drew a little shadow of itself if you went up. And it didn't have boundary checking, so if you got to the top of the screen, it would crash. But the fact remained I had the buttons right, I had the mapping right, I was able to get the value back and show that I could translate it back from a library from CX and DX into the register where QuickBasic expected its return values when you call the library function, which I believe is BX. So, yep, there it is running again, kind of zooming around with it. So this really went faster and easier than I thought. For having never written assembler on this platform and going from 0 to that in the morning, I did that before work one day. All my best stuff happens before work. And that can go next. Oh, back up. Yep, OK. So what did I actually do to implement this? Well, I was talking about the keyboard routines. Because the keyboard is interacted with differently depending on where in the game you are, whether you're in the menu versus whether you're in the live action game, I wanted to interact within the keyboard. There's mouse and there's joystick support in there. But that was a bigger nut to crack looking at the code. There's a lot of inline assembly. There's a lot of things that I really didn't want to deal with. And I figured it's probably easier for me to take the VIS controls, and without getting too deep into it, the keyboard is basically an array of bool for each of the keys in the key table. And when they ran their scan code routine, they would just set the array value, keyboard, whatever, or scan code, to 1 or 0, depending on whether the key was pressed, key up, key down. So that while I can play in that, I can map the buttons on the VIS controller to the specific key scan codes that I know I care about and update the value as the game expects. So I configured the int15 switch change handler. You can see on the right there, the hand control supports polling, and there's a get and set switch change handler. So just like the keyboard, if I do a key press or a key release, key up, key down, it will call whatever address is specified in that register, that set of registers. So I can set a callback handler, create a far call out to my function, and it will come out. Far and near. Let me tell you, you can land into some really bad lands of ghost subs without returns when you're trying to learn the segmented memory model and trying to figure out how to make sure you're far and near and huge pointers and calls and being in the right code segment. I learned a lot. Anywho, I replaced the keyboard support with this. So now they could coexist. I could probably break it out and have both update the keyboard, and you could do both. But for this, I really wanted to make sure that it was just me and I wasn't fighting with myself with a keyboard, so I ripped it out. And you can see on here on the left, I've got the code. So start keyboard became a routine to get the old callback address and then put my new one in there, which is, again, a far pointer actually it's a huge pointer to my function. And then in the right, you can see where I loop through because I get all of the bits back at one time instead of doing like the game did and chopping off all of the remaining keys in the buffer. I take them all and update all the switch values simultaneously. So that came with some challenges. The escape and pause keys are a little twitchy, but I can figure that out. But it does work, and it works fairly well. So onto the file accesses. There are a couple of things that I really had to deal with that I wanted to make sure the game was configured correctly. It does have a KDreams configuration file. And this file talks about, sound, which really doesn't matter too much. Keyboard, I want to make sure the keyboard is selected. I want to make sure that the game starts up the way I expect. If you don't, it will assume a basic configuration. So what I did was on a PC, I wrote kdreams.config as I wanted it configured, and then wrote it to the CD-ROM. It becomes immutable. Calls to update it will fail. The game will continue. Read failures are silent, so if there's a file that's missing, like high scores, you'll just get an empty high score table. Nothing happens. Writes also fail silently, so if it tries to update the high score table, nothing happens. The game continues. So these are things that we can play the game and then come back later and fix if I'm so inclined. So ignore it. Nothing to see here. Now, could I come back later and try and hack in the Save It card? Maybe. I have done a little work in that department, but because the library is Microsoft, that's not as easy as just specifying the lib. And so the two are not compatible. Even if you translate the format to get them correct, the underlying calls that the Microsoft library makes to other Microsoft libraries becomes this you know, what's the phrase I'm looking for? You're basically following a breadcrumb trail and trying to jerry-rig it along. So I have other ideas, but they're memory intensive. So what does this all look like? What does it look like to play Commander Keen and Keen Dreams on the VIS? So I burn a control.tat with it, put my game code on there, power it up, and pray. And of course, this is, waiting for it, I'm going to give you the real-time boot on this, an authorized video information system title, because I'm Class A, friends. This is a Class A title. The game boots up, and we're going to flip here in a minute. It takes a little bit of time to load, but it's not too bad to Commander Keen. So here's my hand control. And now you won't hear it here, but the PC speaker sound does work. And here, I'm going to move around the world here. Now, the VIS controller being infrared, you have to make sure you're pointing it at the VIS. I have a tendency to drop it below the table. I'm really happy with how precise the controls came out. I turn around and zap that guy real quick. That was a pretty Super Mario Brothers-like move there. And the fact that it worked as well as it did out of the box, frankly, surprised me. It was really cool to be able to see this. But it does, in fact, work. I can do these. I can jump between the various things. I can throw the things up and down. The buttons stick. If you let them go, they don't. I updated the help, as you can see on there. So it has VIS button mappings on there and things like that. And the game is, in its current form, playable. There's no save it functionality, of course. The high score names are random. Again, the sound is because of the way the game was. There's no music or anything. It's just your standard PC speaker effects that were in the game. But it has, the code is not yet available, but it will be. I need to write up the documentation for it that 50% of people will read, if I'm lucky. And then I need to I want to put binaries up there and a control tat. So if you get the game, basically the intellectual property stuff, the various game assets, you can put them in the folder with it, burn a disk, and have yourself a playable copy. I can't distribute the game as it is in full because that will probably get me into trouble. The people that run these still care about Commander Keen, apparently. If they didn't, it wouldn't be on GOG.com for $5. So, which, by the way, is a great place to get. I don't think Keen Dreams is on there, but Keen 1 through 6 is, if you want to play with those. Another fun fact, this engine will not run Keen 4 through 6. I tried. So you have to modify it, which someone else did do. So you could probably modify that to do this if you really cared. But it will be available, so more to come on that. You'll see it on my GitHub when it is. So the last thing I did want to talk about here, since I don't have it implemented but have been thinking about it, is the Save It card. So the Save It cards are these Dallas semiconductor cartridges that go in a slot hidden behind a little access door on the front of the VIS. Retail cards are 32K. That's the ones that Radio Shack sold. You got one with the unit. 512K cards were possible. I can tell you the VIS BIOS will only scan for sizes up to 512K. So there's a bit of a limitation there. I don't know if that's a physical slot limitation for the implementation or just that's where they kind of capped it out because that's prohibitively expensive. Near as I can tell, those 512K cards, like the developer cards, are unobtainium. I've never seen them. So maybe they existed then. Applications don't access Save It via DOS ISR calls. This is probably the most frustrating part. There are underlying BIOS ISRs for the Microsoft library to call, but in order to store data on it, it uses a single level table of contents. And this is because a fat file system on a 32K apparatus will chew up more than you want of your space. It's just too much overhead. So I have a simple section based with a byte offset. You access by section name and you tell it, start reading or writing 5 bytes in. And then it will go and do whatever you tell it. And again, mcd.live, mch for DOS, has a very specific order of operations for working with the Save It card. And the modular Windows SDK does include a utility called mcman, which will allow you to manage what's on your card. And I believe it's also built into the VIS ROM, but I haven't triggered it. And again, why not use it for Keen? Well, Keen's written in Borland, and Microsoft libraries are a bit of a thing. Keen is many files, so if you wanted to try and run Keen from the Save It card, the Save It card only supports a single file as a binary. So if you want to run, say, an application from a Save It card, it's got to be your card.exe, and it's got to be combined with a little TAT overhead. So you're looking at about 31K, depending on your TAT file. And it can't access other files on the card. So it's a one thing. The DOS redirector presents it as a single file, card.exe. So that really does kind of limit what you can do with it in terms of testing. It limits what you can do with it in terms of writing things. You've got to go through the Microsoft libraries. And this last one I put on here because it's interesting. We were discussing Save It functionality is disabled on retail units with a big asterisk. I was looking into this. The problem here is without having a way to write a bootable Save It card, I don't have a way to test. Where I read that it was disabled is in the VIS BIOS change log. And it specifically says that there was a Phoenix BIOS routine in there that would take code from the card. And it looks like it was any code from the card. That was disabled in the retail ROMs. And this makes sense. It was used for trying to bootstrap the operating system on a thing when you didn't want to commit it to ROM necessarily or try and burn it and deal with it. So you would put it to a Save It card, pop the convin, and the BIOS would boot from the Save It card. But what it doesn't clarify for me is when you get the VIS screen that says insert disk or cartridge, you're past the BIOS. MS-DOS is running, and you're in an application called T-Launch. T-Launch is the application that will scan your CD for control.tat and tell you it will or won't play the disk, or if you put in an audio CD, it will run the CD player application, which is, I guess, the de facto shell if you don't have a modular Windows disk in there. That T-Launch, because it relies on the license file and the licensed architecture, may still support booting from the Save It card. But without having a way to write a bootable Save It card, I don't have a way to test. What I think I can try and do, if I can coax a way to get it out there, is to make the combined Save It, make TAT-M, and binary utility, just something small that just pops an image on the screen or something, or draws something. And write an application that on the VIS will write that out to the card. If I can do that successfully, I should then be able to boot from the card, assuming I get the format right. But because I don't have a working unit to compare it with, and you'd need the development cards and that software to do it, I don't have a way of knowing whether what I'm really doing works. And I don't really have a way to read or write a Dallas semiconductor in a modern operating system. I can't throw it in a Linux box and DD the thing or anything or dump it. So for now, I think that I suspect that with what the disabled text was referring to is the BIOS's ability to boot untrusted code from a Save It card. That would make sense that it would have been removed. But I think, if I'm reading it right, that it will still boot a signed application from the Save It card. And where are we with the Save It card process? Well, this doesn't use file handles. So, see, you're getting an F open, you get a file handle back, you use the file handle when you're F write, F read, right? You're not going to get any of that. When you initialize and access the Save It card, VIS tracks internally which file, which section you're working with. And until you tell it differently, it continues to work with that file. So you have to be explicit. You, in everything you do between that and your offset, are responsible for keeping track which section am I working with and at what offset. Where am I working? How is my file formatted? That's all on you, the developer. So you init the subsystem. You don't have to do this in modular Windows, but DOS you do. Register your application's name. So you give it MC register, you give it a string with a name, and that last parameter, MC auto format, you can tell it not to auto format the card, but there's really no good reason not to. Neat little addendum to that with the name. If you separate a name and another name with a %, when you look at it in MC man, it'll basically give you a title and like a subsection nicely formatted. So you can say Keen high scores, Keen level save, or whatever you want like that. So that's nice for rendering it if you want to do subcategories for your users if they're managing it in MC man. You allocate your space and you give it a buffer size. And then you read or write your payload. So in this case, we're writing. You give it an MC write. Now, again, you tell it the offset you want to start writing at, 0 bytes in, 64 bytes in, whatever it is. And then you feed it a pointer to a buffer, that is at least the size of what you told MC alloc, because it will walk the distance that you said in the buffer size. So if you give it 10 bytes and you have a 10-byte string, and it's only 10 bytes in size, char string 10, and you gave it a buffer size of 32, it's going to walk 22 more bytes. So you might get data on your save it card that you don't like, or worse. And finally, you deinit the system. You give it an mcinit with mcend. And again, you don't have to do that in modular Windows. Modular Windows takes care of that for you. And that's basically the functionality of the save it card. It's really easy. I did write with Microsoft C++7, a small application to write out a payload to the save it card with my name and subsection and the text, hello, you rummy buzzard, TRS-80 Model 3 reference there for you Tristas fans. And it does work. It reads and writes, and I'm able to get the payload back and forth. I have an application to read it and an application to write it. So it's pretty straightforward to work with if you're in the Microsoft ecosystem. And that's the save it card. So with that, I want to end with you guys for a quote from one of my favorite movies, War Games. I love all those Cold War technology films. Dr. Falcon, if you haven't seen the movie, I'm going to ruin it for you. The end of the movie is at NORAD, come out of retirement. He's talking to General Behringer. He tells him, General, you're listening to a machine. Do the world a favor and don't act like one. And this is advice in and out of our computing lives I think we really need to take to heart. So many times now, especially with this and algorithm and the AI robots telling us what to think, we surrender our agencies to whatever our feed tells us, whatever someone else tells us. React without giving it a thought. And I think we would all be better off if we took a little time and kind of experienced the 64 grades of shades of gray that are humanity, not just black and white. So that is my presentation. I realize I only left about 4 minutes for questions, unless you guys don't want to eat. So thank you very much. Any questions? And I realize I fire hosed you.
Are there still units out there available?
I'm sorry, say again?
VIS units.
VIS units available? Yes-ish. I don't want to put them on the hook for it, but I know Tandy Showcase at Malfris actually had some folks buy some here. So if you reached out to him, could work something out with you, or at least let you know when or where they'll be available. He has a pretty good stack and has been talking about unloading some of them, but I don't want to put him on the hook to just sell him VISs. He's going, what did you do? So, yeah, Joel?
What did you use to determine what the sound and MIDI capabilities are? So do you have more detail?
The sound and MIDI capabilities, all of that is actually just very well documented in Tandy's doc. So visbios.doc was really my reference for a lot of this. I will tell you, I kind of skimmed over it here. AdLib, in addition to being available via BIOS IOSR call, is also available with the standard ports, 388, 389. So if you're used to working with AdLib, applications that access AdLib through the standard AdLib Gold ports will work. Prince of Persia makes sound when you run it on the VIS. So excellent. Everyone wants to eat. Alrighty, thank you, everyone.